Hello and welcome to our session. We'll be talking about the perimeter and area today. So we're going to look at some electude problems, and then also you'll have an assignment. So let's share my screen with you. All right, so we're talking about perimeter and area, okay? And so let's talk about what the difference is. And this is chapter 17 of your textbook. And so when we talk about perimeter and area, we'll be dealing with the polygons, which have angles and sides, and we'll be dealing with the circle, okay, which is not a polygon. And we deal with perimeter, we're looking at the outside. Okay, we're dealing with area, we're looking on the inside. Okay, and perimeter is basically when you're dealing with a polygon, it's just basically adding the sides. Okay, just walking around to add the sides. And then with the area, it is dealing with multiplying. Okay, and so finding the area of the inside. And so you have different formulas when you're dealing with the area. And then the circle, when we talk about perimeter, we're talking about the circumference. So circumference is equal to your 2 pi r. And then your area is equal to pi r squared. And so when we think about this, remember that when you're dealing with a circle, we have a center, okay? And then your diameter goes through your center, all right? So it doesn't matter where you are, as long as it goes through the center. We'll pretend like that's the center. All right, and so your radius is half your diameter. All right, and then we deal with and then pi, here pi is actually a number. That's 3.14227. And so it's pi times r squared for your area. All right, so we're going to let's look at the electude and see some examples there. All right, so on your electude, and those who are in the automotive and you are familiar with this, all right, and so we'll look at some of the problems in your electude. Okay, and so it talks about static radius, okay, and so it says when tires are inflated, they have a particular diameter. When unloaded, the radius is half the diameter. We just discovered that. So we're dealing with this, a circle, okay, pretty much a circle. When the wheels are underneath a car, it says the tires are pressed down against the road surface. So the radius you now measure is called the static loaded radius. Okay? And then it says the static loaded radius is the distance from the center line, okay, we have a center line here, of the wheel to the road surface when the car is not driving. So here we have a ruler, okay, we have a tire. It says you can drag the ruler with the mouse. So if you are using this, then we can actually move the ruler, okay? And we've done measurements in another chapter. And so here it starts from 0 and it goes all the way up to like 75. All right, so it says, what is the diameter of the unloaded tire? And so basically you may have to put a piece of paper on top just so you can actually see it, okay? So it looks like, and if you put a piece of paper, looks like it's at 60, okay? And so this is in 60 centimeters, so we'll put 60 and see if that'll check out. Let's put it, okay, good, so we're right. All right, so we're just using the measurement to measure the tire, the diameter. Okay, and then so you can drag the ruler with the mouth. What is the radius of the unloaded tire? So we already know that the radius is half your diameter. So basically, and it gives you a center line, okay, on the tire. See that line that goes to the center? And so we can measure that, and it should be 30 because if the diameter is 60, then the radius should be 30. So let's check that out. Good, so we're right on that. Okay, so now we have a tire that has been loaded, okay, to the car. And so it says the tire is under the car and supporting weight. And it says, what is the radius of the tire car in this situation? So it's not moving, okay? And so they've already given you, you know, what the static loaded radius is. So it says when the wheels are underneath the car, the tire press down against the road surface, and this is called your static loaded. So we can know that is static. Just reading. Then it says you can drag the ruler with your mouse. Okay, and so the ruler is already beside the wheel. Okay, and here now it says how much is the loaded radius, and so it tells you that it's not moving. All right, so we're going to look at this now. Notice here. Let's look and measure. This time it's a little less. Let's look. So it's not at 60, so it's probably more like 58. Let's try 58. Nope. All right, so let's try it again. Let's look at it again. My angle. Almost at 60, but looks like my. Let's try 59 and see if that'll work. No? All right, let's see. Let's see it again. Maybe you can see it from my angle. It doesn't look like it's still at 60 though. Let's look at the, we can look at the, here we go, the radius more. So, and that's more at 28. So 56 then. So that's what we have to do. 56. Check. No. Okay. Let me look at it again. 28 and 28 will be 56. I think I put in 50. Let's see. Let's see. That radius looks like it is at 20, 28. So, oh, they're asking for the radius. Okay. Not the diameter. So 28. That would be, it's important to read the directions. So I'm looking at doing the diameter first, but they asked for the radius from this pointer stand. So we were looking at the middle, the center. So we were putting in, so it was 28. So, and I was trying to do 56 based on the radius. All right, so that is, dealing with your diameter and your radius of a tire, dealing with the static radius. And again, the static loaded radius is when you have a wheel underneath a car and the tires are pressed down against the road surface. And so we can see that analyzing from outside from underneath the car, just the wheel itself, the radius was at 30, okay? But when it got underneath the car, then it decreased. All right, so that's dealing with okay. So now we have the dynamic radius. So the car is moving. All right, so when the car is driving, the centrifugal force is exercised on the tire. Force makes the radius of the tire bigger. And so this is called the dynamic radius. And so the faster the tire rotates, the bigger the dynamic radius. So here, it's just asking you to read and to answer questions based on what we just read. And so it says change the speed of the car using the slider. And so if you do that, we can see that we are, and we can see as we increase, that's changing, right? Okay, so it says, what do you notice about the tire when the car drives faster? Okay, and so here we can see that it already told you, the diameter of the tire. Increase size. All right, so it says the faster the tire rotates, the bigger the radius here. And so if we're talking about the diameter, the radius and the diameter are related. Okay. And then it says what force makes the tire expand. Okay. And so here it says when the car is driving, the centrifugal force is exercised, and then it makes the tire bigger. So I was just asking you to read and check. All right. And then this is talking about what is the radius of the tire called in the situation. And this is the radius, the dynamic radius. And what is the distance of the dynamic radius? And it says that the distance is from the center line, okay, of the wheel to the road surface when the car is driving. So basically it says here the distance from the wheel center line to the top of the tire, or this is the distance from the road surface to the wheel center line, okay? And so basically that's the same thing. All right, good. I think that's, okay, so rolling circumference. So circumference again, with the circle is 2 pi r. Basically here, it's asking us to, let's see, the rolling circumference is the distance a tire travels in 1 revolution. So we're talking about 1 revolution, that's a full 360 degrees. All right, so the rolling circumference is important for the speedometer. Tires with different rolling circumferences are put on the car, then the speedometer will no longer indicate the correct speed. So it says, what does the rolling circumference mean? Okay, and then it says that this is the distance the tire travels in 1 revolution. This is the distance the car travels after 1 crankshaft revolution, or this is the distance a tire travels in 4 revolutions. And so this is, for 1 revolution, circumference. Okay. All right. So here, good. Then it says drag the tire to the right using the mouse. So basically here, I need to put it. Let me put it at the here. So that's at the 0 mark. Okay. So I'm going to drag it to the right, and then it's asking what is the rolling circumference of this tire. Okay. It's asking what is the rolling circumference of the tire. So let's roll it. And so now see this line, this white line here. All right, so let's roll it. Oops. Roll. Okay, so that's 1 revolution. So what is the rolling circumference of the tire? Again, the rolling circumference is the distance the tire travels in 1 revolution. So we can see that 1 revolution, that's at like 190. Let's see if we're correct. Okay, good. And I don't need to do that. Okay, so basically I just wanted to cover that. This one here is, it says what changes when you install a tire that is a different size. All right, so changes, the rolling circumference changes. Let's see, the diameter changes, the radius, that changes. So the final drive gear ratio, so the ratio was still, whatever, that ratio will not be changed. So let's see if we are right. Good. Okay, so hopefully that you understand how to find or how to deal with um, the radius and the diameter of a tire, whether it is outside the car or up underneath the car, and also what constitutes one revolution, okay, of a tire rolling circumference. All right, good. So now I wanted to go over some other things. Now, with the horticulture, now you also deal with the parameters and areas, and it may be in relationship to the yard. Okay, it may be a triangular yard, it may be a rectangular yard. All right, so we're going to look at some of the setups here. All right, so if we look at some of the examples, all right, the first one, yeah, I have my, all right, so the first one here we have is the base of a triangle is 14 inches and its height is 2 inches. What is the area of the triangle? So let me put this on the board. All right, so here I like to draw a picture. We have a triangle. I'm doing the first one. All right, so basically let's draw a line to do the height. Height, the tip to the bottom, the base. So that's the height. And then we have the base. And so when we find, and we're looking for the area, so area of a triangle is 1/2 the base times the height. That's the formula. And you should have a formula in the back of your book also. So, or in chapter 17. The base of the triangle is 14 inches and its height is 2 inches. All right, so we have the base is 14. So we'll make the substitution, the height is 2. And so here, we're basically solving this expression, simplifying this expression to find the area, okay? So we can basically just take half of 14, which is 7, and then multiply by 2, so we get 14. So no is in inches. So now when you're dealing with the area, it's always square. Why is that? All right, so basically go back to the laws of exponents. When you have x times x, that's x squared, right? So inches times inches will be square inches, or inches squared. And so then when you get into volume, just so if you're dealing with volume, that's 3, so that's cubic inches. So that's x cubed. If you have inches times inches times inches, then that's cubic inches. That's why you have, when you're dealing with volume, it's always measured in cubic units. Okay, good. Just wanted to just throw that out. And now here, let's see here. Well, let's look at number 2. We have the 2 parallel sides of a trapezoid. All right, so trapezoid looks like this. Okay, excuse my arm drawing. It's lopsided. But okay, so we have the two parallel sides. All right, and so the 2 parallel sides. All right. All right, so 2 parallel sides measure 15 and 13, so inches. So this is the smaller base, so 13, and this is the bigger base, 15. All right, so if the height of the trapezoid is 9 inches, what's the area? So again, we'll do the height. Oops, height is 9. So when you're dealing with the area of a trapezoid, I want to say it's half of the sum of the 2 bases, right? And then times the height. Okay. All right. And so again, When you're dealing with the formulas are included at the back of your textbook. So again, it probably have the H in the front. So 1/2 times H, and then times the sum of the bases. So the sum, so we got 1/2 times 28, and then times the height. All right, and so go ahead and calculate that. Okay, again, you can take 1/2 of the even number, because that's easier to do, right? And so that would give you what? 14. And then do 14 times a 9. And so you get an area of 126. And then I guess it's inches. So that's square inches. And square inches now, because you added inches, that was still inches. And so then we have inches times inches of square. All right, so I think you get the picture of how to find like the area, okay? And these are all dealing with the area base. And so you can use the formulas on the area. So if it just asks for the perimeter, then we would just go on the outside, just add the lengths of the sides on the outside. All right, and also, let's see, if you have, you can do like a formula sheet, geometry formula sheet, and it will also give you the different formulas. Okay, and so to find the area. And again here, so we just dealt with the trapezoid. All right, and to find the height, and we use the right formula. Good, and this is also with the triangle, and it just varies on how they do the height. So it's from, a top to the bottom. Depends on how your triangle is drawn. So you have a formula sheet here. This probably looks just like the one that's in your book, almost, in the back of your book. Okay. So now you have dealt with finding, you know how to find the perimeter, I think you know how to find the area. I wanted to share with you some of the problems in your, for the auto mechanics who have taken the electude, to see some of the problems in reference to the radius of a tire. So that concludes that mini lesson, and so I will send to you your homework. Okay, so I'll post it in Blackboard, and I'll also send it to you by email.